Welcome to all. In Part-7, in this presentation, going to discuss about a Recuperator. The Recuperator is one of the important device which is used for waste heat recovery management. Here, the gas inlet and the outlets are showing the schematic diagram. Air also entered through the wall surface and exit at the top of the schematic diagram, where the air is carrying heat from the gas flow line. In order to we can able to reduce the heat of gas, or else we can improve the heat of gas. This is the way they are following in this Recuperator method. There are different types of recuperators are there. Already we have discussed about recuperator in that previous part. In this part we are going to see the fundamental details about the recuperator. The first one is convective regulator, where we can see the cooled waste gas port and heated fluid exit port, hot waste gas port, and cool fluid port. In the cool fluid port will allow to enter the cooling air or water system. In order to the hot waste gases can able to maintain or control their temperature by using the cool fluid system. After entering the cool fluid system contact with the hot waste gas tube in order to the cooling fluid carrying the heat towards the exit of the port. This is the way the convective regulator is working. This is convective radiative regulator, another schematic diagram. Previously we have seen that horizontal wise construction regulator. Here this is vertical type regulator. Here we can see the radiation section, the convective section, and cooled waste gas or chimney section. The cold air inlet is entered on the wall surface, and the hot air to process, and the cooled waste gas outlet on the top. The gases is allowed to enter at the bottom of this regulator. Initially the bottom section is radiation, which means where allowing the air able to convey the heat through the radiation. And the second section, the air connected with the tubes in order to remove the heat from the tube surface directly, so that it is also called as convective section. This is the way the recuperator process is going. The ceramic recuperator is shown. This is industrial ceramic recuperator, where we can see the small tubes, and the end of the tube can see a flat surfaced plate. In the inside plate will have air circulation port. In the tube will convey the gases, so the circulating the air will remove the gas heat energy in order to maintain the gas and this is another one recuperator. That right hand side can see the air outlet. The left hand side you can see the gas inlet tubes. this is horizontal type recuperator, radiative recuperator, and also regenerator preferable for large capacity used in glass and steel melting furnace. Here the regenerator schematic diagram is shown in this figure. Here the regenerator is located at the outside of the regenerator body. The gas regenerator is located at the inside of the regenerator body. Here the gas enter through the element this is the top portion is look like filtering element, and then the gas allow into the chimney, and another one side the air will enter. Accordingly that air will carrying the heat and then it will exit with the heat. The time between the reversal is important. Long period increases thermal storage costs and result in lower average temperature of preheat and reduce fuel economy. Accumulation of dust and slagging on the surfaces reduce efficiency of the heat transfer. This is heat wheel. The cool air will enter from left hand side to its right hand side, as well as the hot gases will enter from right to left hand side. In order to the heat maintain by supplying the cool air. This is the heat wheel of the regenerator, and this is schematic diagram of 3D heat wheel. It is a sizable porous disc fabricated with material having a very high heat capacity, which rotates between two side by side ducts, one a cold gas duct, the other a hot gas duct. As the disc slowly rotates, sensible heat is transferred by the hot air to the disc, and as the disc rotates from the disc to the cold air, overall efficiency of sensible heat transfer for this kind of regenerator can be as high as 85%. The overall efficiency is higher due to this regenerator. Also, a heat wheel is finding increasing applications in low to medium temperature waste heat recovery system. In the waste heat recovery system consists of different types of equipment. There are different types of recuperators are there. According the industries and their requirement and required product output, they can use those different specifications of recuperator. Also the cost one of the influence to select the recuperator. If the industry is going to generate low power or medium power, according the low cost recuperator is suitable. If very high power generation stations should create a good quality recuperator is necessary, where they can able to maintain this all these things like the maintain the heat supply and manage the airflow system. Everything will be involving in this recuperator system. The heat wheel also is finding increasing the application, which means due to the cycles and there are different applications are there. So the heat will is also very important to in the regenerator production for maintaining the waste heat recovery system. Thanks for watching. This continuation will be the next part. Within this